Today I'll talk about partial pressure, vapor pressure and ideal gas law. Here is the definition of partial pressure. The partial pressure of a component gas in a mixture is the pressure it would be exerted if it alone occupied the same volume at the same temperature. Now next is pure component volume. The pure component volume is the volume that a component gas would occupy if it alone were present at the same pressure and temperature as the gas mixture. And then next is Boyle's law. So what is Boyle's law? Boyle's law states that for a given mass of an ideal gas, the product of the pressure P and volume V is constant at a constant temperature. So PV is actually constant. Now Charles' law. Charles' law states that for a given mass of an ideal gas, the ratio of the volume to the absolute temperature T is constant at a constant pressure. So V by T is equal to constant. Now next is ideal gas law. Combining Boyle's and Charles' law, we get the ideal gas law. So PV is equal to N at T. Now here P is pressure in kilopascal, V is volume in meter cube, N is number of moles in kilomole, and R is the universal gas constant, that is 8.314 meter cube kilopascal by kilomole Kelvin, and T is the temperature in Kelvin. Now here example of ideal gas law. Calculate the pressure exerted by 2 moles of an ideal gas in a 10 liter container at a temperature of 300 Kelvin. Now here given N is 2 moles and then V is 10 liter, so that we can convert to the meter cube, so that will be 0.01 meter cube. So 1 liter is equal to 0.001 meter cube. Then T is given 300 Kelvin. Now R is that meter cube, kilopascal, kilomole, Kelvin. Now we know that from the ideal gas law PV is equal to N at T, so we have to calculate P. V is given 0.01, N is 2, R is 8.314, T is 300. Now if we do the calculation, then we will get V is nothing but 498840 kilopascal. So pressure exerted is 498840 kilopascal. Now what are the key factors of the ideal gas law, or key facts, not factor? The ideal gas law states 3 facts. So volume of gas is directly proportional to the number of moles. So here V is proportional to number of moles. Volume is directly proportional to the absolute temperature, V proportional to temperature, and volume is inversely proportional to the pressure, V is inversely proportional to the pressure. So now unit of universal gas constant R. So when P is in kilopascal, V is in meter cube, N is in kilomole, T is in Kelvin, then R is 8.31451 meter cube kilopascal by kilomole Kelvin. When P is in megapascal, R is equal to 0.008314 meter cube megapascal kilomole Kelvin. When P is in ATM, so that is R is 0.08206 liter ATM mole Kelvin. When R can also expressed as 1.987 kilocalorie kilomole Kelvin or 8.31451 joule per mole Kelvin. Now next is NTP and STP condition. So normal temperature and pressure, so that is called NTP. Temperature is actually 0 degree centigrade, so 273.15 Kelvin. Pressure is 101.325 kilopascal. Molar volume is 22.414 meter cube per kilomole. And standard temperature pressure is 288.7 K. Pressure is 101.325 kilopascal. Molar volume is 24.465 meter cube kilomole. Now based on this condition, we can calculate R also. Now calculating universal gas constant R using an ideal gas law at NTP, R is equal to PV by NT. So now we know that PV is equal to N at T. So from that R is equal to PV by NT. Now at normal pressure and temperature, so temperature is 273.15 Kelvin, pressure is 101.325 kilopascal, and molar volume 22.414 meter cube per kilomole. So N is 1 mole. So that is that per kilomole. So now here R is 101.325, that into 22.414, the N is 1 kilomole, and then or 1 number of moles, and that is temperature is 273.15. Now if I do the calculation, we'll get that R is 8.31451 meter cube kilopascal by kilomole K. Now if you can remember this condition, so you don't have to remember what is the R value, so you can put that proper unit, you can easily get the R value, or if there is a different unit you can change, and based on that unit you can get R value. So don't remember what is the R value, you can easily calculate if you remember these things. I always recommend you just remember that enthalpy condition for ideal gas, and you can easily calculate the R value. Now changing condition. Now if the volume, temperature and pressure of the gas change, we can use the ideal gas law to calculate new condition. Like initial value is V1, T1 and P1, and final V2, T2, P2. So we can easily calculate using ideal gas law any condition. So using ideal gas law, we can write P1 V1 by T1 is equal to P2 V2 T2. Now here one example actually I gave. So P1 is given, V1 is given, T1 is given. Now calculate V2. So P2 is given and T2 is given. Now we know that P1 V1 by T1 is equal to P2 V2 by T2. So now we have to calculate the V2. So P1 is given, V1 is given, T1 is given, P2 is given, T2 is given. We can calculate V2. So here V2 is nothing but 11.2 meter cube per kilomole. So the new volume V2 is 11.2 meter cube per Kelvin. So that's it for today. Thank you.